So today we're going to take a look at the surface area of prisms. Here's an example problem. So suppose that we need to wrap a gift as shown below. So imagine this is our box. We've got a 12 and 10 and 20 length, width, and length, width, and height. Okay. Now we need to figure out what the least amount of wrapping paper we need is. Okay. So in order to do this, we are literally going to have to create a solution that takes into account an exploded view of what we have for our box. So the first thing that we have to do is we have to sketch a net of the box that labels all of the sides so we can figure out the areas of each of the individual parts, which are the same. So you'll notice that we're going to calculate once for each of the areas of AC, B and D, and E and F. So the area of the face for A and C is equal to, well, length times width, which is 12 times 10, which gives us 120. The area for the faces of B and D is going to be 12 times 20, which gives us 240. The area for E and F is 10 times 20, which gives us 200. Now, we're going to add the area of all the faces to get our final solution. So when we add the areas, there are 2 times 120 plus 2 times 240 plus 2 times 200, which gives us a final answer of 1,120 centimeters. And you'll notice that every time we're doing surface areas, everything comes out to be in squares. So suppose you needed to wrap a gift wrap below. What's the least amount of wrapping paper? All right. This is how you answer it. To allow for overlap when wrapping presents during the holidays, you're going to have more, just slightly more than 1,120 centimeters squared of wrapping paper to wrap the box. And that's it. We're done. All right. So the next problem that we have is given by this nice word problem. It says the base of a rectangular pyramid is 6 centimeters by 8 centimeters. The height is 5 centimeters. I need you to find the surface area of the pyramid. So this is essentially what we have for our basic pyramid, okay? We have its base here and here being 8 and 6, and then its height being along here, okay? Now, the only issue that we have here is when we're trying to find the surface area, we're literally trying to find the area of this face of our triangle, this face of our triangle, this face of our triangle, this face of our triangle. Now, this face here matches with this face, and this face matches with this face of our triangle. So what that allows us to do is it's going to allow us to figure out what we need for our heights for this portion and this portion. So we only have to calculate two sets of triangles, and then we also know how to calculate the base of our pyramid. So here's the basic solution. We have to find the height of the triangular face, i.e. the slant height of each triangular face, otherwise known as the slant height. So right now, what we're going to do is we're going to go and find the slant height for the y side of our pyramid, okay? So when we're finding our slant height for that, here's what we say. You got to remember that our original triangle, when we draw it, it's going to look something like this. It's going to have dashed lines down and dashed lines across, but we need to find this half of our triangle, this highlighted part of our triangle here, okay? So now this is a right angle triangle. The distance along this portion of the triangle here is exactly half of this 8 that I have here. So what we're going to do is we're going to use, instead of 8, we're going to use 4 on the base of our triangle. Now, the height of our triangle comes from here. The height of our pyramid, which is actually 5. So here we go. To find this portion of our triangle, we have to use Pythagoras' theorem. So we start with, let's call this y, like we said before. So now we have y squared is equal to 4 squared plus 5 squared, which is 16 plus 25, which gives us 41. So y squared is equal to 41. So y is equal to the square root of 41, which is approximately 6.1. No, 6.4. So that's what we get for our y value. It's approximately 6.4. So now let's do the same for our x calculation. So for our x calculation, here's what we have. We are looking for the x side. And in this case, what we're looking for is this portion of our triangle, right? Now, we can follow the same pattern that we did here to find y. Now, the distance, the triangle that we have here is going to look like this. And it has its hypotenuse, and we're going to call this x. Now, the distance along here is parallel to this, so that means this is 6, so half the distance across is 3. So we're going to put 3 for our base. Now, its height is still 5. So now we're going to use Pythagoras' theorem again to find our x value. So we have x squared is equal to 3 squared plus 5 squared, which is equal to 9 plus 25, which is equal to 34. So x squared is equal to 34, isn't it? So x is equal to the square root of 34, which is approximately 5.8. So now we know the height of this side of the triangle and this side of the triangle. So now let's go and sketch a net based on what we just learned of this pyramid. So now we'll go and sketch our net with all the information we have. So based on what we had from before, right? If we have all of these sides labeled, right, we've got the following. We've got a mesh laid out with our 8 by 6 side, and when we calculated our 8 by 6 side, you got to remember that we calculated y by doing that right angle triangle for this, right? To figure out that we had 6.4 for our calculation for the height of the triangle, right? And then we did the same for our x value using the right triangle again, the right triangle calculation again, for this and this. So we have this mesh here based on what we just learned. So now let's go on to the calculations, okay? Based on all the information that we have here, we know that P and Q, that sides P and Q are the same, and sides M and N are the same. Now, just remember that when you say that something is the same in mathematics for a shape, you're actually saying it's congruent, right? So let's go and calculate the area for M and N. So the area is equal to 1/2 B times H for our basic triangle. So let's just calculate 1 and then we'll multiply it by 2. So we got 1/2 of 6 times 6.4. And that gives us 19.2. And that's what we get for our A value. Now, remember, there are 2, right? So that means we have to take the area of M and N is equal to 2 times 19.2. So we end up with 38.4 for our answer for A of M and N added together. Okay, now let's go over to the faces for P and Q. So the area is 1/2 a base of our triangle times the height, which gives us, well, 1/2 times 8 times 5.8, which gives us 23.2. But you got to remember there are 2 sides that are the same. So we end up with A of P and Q is equal to 2 times 23.2, which gives us 46.4. So the area of P and Q is that. Okay, and now we just have to find the area of the base of the square. So let's figure it out. The area of the rectangle on the bottom is going to be just A is equal to length times width, which is 6 times 8, which is 48. So the area is 48. And the total surface area. So notice, we need to calculate a total. The total surface area is equal to the following. So you got your 48 from here. You got your 46.4 from here. Plus the 38.4 from here. And you end up with the total surface area equaling 132.8 centimeters squared. So you're going to say therefore the surface area area is 132.8 centimeters squared. And you'll notice that every time we do this, the surface area is always squared. So here are the key concepts for the surface area. The surface area is the area of all the sides added up. The surface area is measured in units squared, otherwise known as square units. So for basically a rectangular prism, okay, what you need to do is this. You need to make a mesh, and you need to make sure that the mesh sides are labeled. You need to calculate the matching sides for each shape. All right? And when you calculate it, you're literally just calculating the area. And then all you have to do is add up all the sides areas. And so for the surface area of a rectangular based pyramid, we do exactly what we did before. But the first thing that we have to do is we have to calculate, one, the slant heights. So find them. Okay, you can always refer to our video for this one. And then two, the next part, you have to make a mesh. And you want to label them. Then three, you're going to calculate the areas for matching sides. In this case, there are 2 each for the triangles. Okay, and then 4, calculate the area of the base of the rectangle in our triangle. And then 5, add up the sides. Add up, let's say, all the areas. Okay, and that's it. That's what we learned about today.